Okay, so last time we have completed like OSPF basic theory. What is OSPF? What is OSPF administrative distance? OSPF works on area. Okay, and we talked about OSPF messages, and you already know that OSPF have five type of messages like hello, okay, which is known as type 1, okay, and hello is used for discovering the neighborship, you know, okay. Now
Yes.
type 2, which is database description packet. Then you have type 3, which is known as LSR, link state request, means if you are missing any information, network information, so you will send a request LSR to your neighbor, and neighbor will update you with the missing routes with LSU, okay, link state update, and then finally you will acknowledge, yes, I have received your packet, right? Now we have already checked about hello packet content,
Yes.
and we have verified that okay, what is OSPF hello packet, okay, and what are the contents inside hello packet, and these hello packets is used to form a neighbor relationship with the routers, right? And we have checked all these things through a packet, Wireshark also, these all options, and we have verified. And after that, like, we have to work on OSPF neighborship condition. Like if this R1 wants to be a neighbor of this R2, so the both router have to follow some kind of condition that okay, I want to be your neighbor. So okay, you have to follow this, you have to follow this. So here is saying that OSPF
Yes.
router will become neighbors if the following parameter within a hello packet are identical on each router. Means these all informations what we
Yes.
are getting here, these all informations will be shared with the neighbors in hello packet, and when if whatever is here all will be identical, okay, then these both router will become neighbor. If then no, okay. So here is saying
Okay.
that area ID must match. Area ID means you know that OSPF works on the condition of area 0, area 1, area 2, like that, same like Eigrp autonomous system number, right?
Yes.
So if you want to communicate, your area ID must be same. So here also area ID must be same. Now in OSPF network, every router will have router ID. So here is saying that router ID do not match. So router ID must be identical on each router. Okay, here also different, here also different. If it will be same, no neighborship. Okay,
Okay.
area type, this stub NSSA we will come to know later, this one, and this flag will come to know later. Okay, now prefix and subnet mask must be same, like you can see here it is /24 here, here also /24. The link which is connected directly, it must be same, okay, and if it is different, they won't be become neighbor, okay. Now
Good.
hello time and dead time, but in Eigrp hello time dead time, if it is different you can become neighbor, but here if hello is different and hold is different on the neighborship, so no neighborship, okay. If here is different, here is different, then no neighborship, neighborship will come down,
Okay.
okay. Now now is talking about network type. See, in OSPF we have different type of network type, okay. If we are connected with Ethernet, so it is a broadcast, okay. If we are
Yes.
connected with serial, it's a point to point. If we are connected with some frame relay link, so it's a non-broadcast multi-access. So we will see those things later on. So network type must be same, okay. Now authentication type, authentication data, it's optional, but if it is applied, you have to um,
They have
yeah.
to.
So authentication type means, like we have two type of authentication type. One is
Yeah.
normal text and MD5.
Oh, sorry.
Yes,
Independent.
and data is your password. Okay, Mtu size, this is important. See, whatever condition, whatever we are getting here, we all, these all condition we will check one by one in our practical session. That okay, see, area ID is same, so we have neighborship. If different, neighborship break, like this all condition will check. We have a separate session on this, okay?
Okay.
And why we will have the separate session on this, because for troubleshooting we it always helps, okay?
Yes. Yes.
Okay, Mtu size, you know that maximum transfer unit is by default is 1500, but maybe if any engineer has changed to 1500 to 1400 or 1000, okay? So if you want to become neighbor, so by default your is 1500, and here by engineer someone has changed to 1100, so no neighborship, okay? So we have to
Yes.
check, okay, how to check a MTU, how to make it equal, okay? Now
Okay.
OSPF stub flag, we will see this, what is the stub network. Okay, okay, network type we have already discussed, okay? Now see, no, these all informations what we have talked now, okay? So these all information they exchange in hello packet. So whenever they exchange hello packet, you will find all information. So if all is okay, then you will become neighbor, okay? Now hello packet
Okay.
is used for sending keep alive message also between neighbors, and check whether the neighbor is okay or not. Once the neighborship is done, so they send keep alive message to check whether the neighbor is okay or down, okay? Now, and these hello messages also keep track of the neighbors, like who is my neighbor, what is the priority of the neighbor, what is the state of the neighbor, from how long it is connected, and how after what time it will be, dead time is 40 seconds, hello is 10 seconds, what is the address of my neighbor, okay, what is the my interface which is connecting to neighbor, and how we can check. So IP ospf neighbor, same like eigrp command. So IP eigrp neighbor, okay?
Yes.
Now but here it is little bit advanced than eigrp. Here you can see that ospf neighbor type, or you can say neighbor formations. Like here in ospf you will have two type of neighbor, okay? One is neighboring router, okay, with whom you just exchange hello message, okay? And one router, okay, you exchange database, okay? So then once you will exchange hello, you will become neighbor. But one router you exchange hello and database also, that is known as adjacent router, okay?
Okay.
Yes. So adjacency will be formed only with which router? Like in future you will come to know about DR, BDR concept, right? Okay.
Yes.
Yes. So these routers will become adjacent router, and normal in broadcast network you will have two type of neighbor, okay? Neighbor router, okay, and adjacent router. But in when you have point to point link like serial link, right? Okay.
Yes.
Okay, in that you will have only one neighbor which is known as adjacent neighbor, okay? Now here in ospf you have some neighboring states, like okay, what steps ospf follow to become neighbor, or fully neighbor, or adjacent neighbor, like that, okay? So now see, when you have router 1 here, here is router 2, okay? You configured IP address, see the process, you configured IP address. After that you will enable ospf, right? So when you will enable ospf, you will enable ospf here first, and then you will enable ospf here, right? So once you will enable ospf, okay, then the ospf state will be down. Why? Because once you will enable ospf, this guy will start sending hello message. So this guy will send hello message, but R1 will not receive any response. Why? Because here there is no ospf router running in the network, okay? So if any
Okay.
message, whatever you are sending hello message, you are sending this is hello, this is also hello, but you are not getting any response from your neighbor, means there is no one on the link, okay? So now after that, once the both place you will enable the interface, means both is running as a ospf router, okay? Then the second process is second state, you can say it's init state or initialization state. In that you will send hello message stating that I want to multicast this hello message on 224005. And why you are multicasting? Because you don't know your
Yes.
neighbor. Who is my neighbor, right? You are just multicasting it, saying hello, hello, who is OSPF router? Okay, and you will advertise like, okay, I want to communicate to OSPF routers and my router ID is 1.1.1.1. Then this router 2 will say that I received hello from R1, but my router ID is not listed in hello message. Okay, so no problem. Then router 2 will say that this is my hello message. I want to multicast on 224005 in OSPF network and my router ID is 2222. Then here also he will say that yes, I have received hello message from R2, but but I am not listed as his neighbor. Are you understanding? Then see second. Then it will come to third state, which is known as two-way state. In two-way state, see how they are sending.
Two.
Yes. Then they will say that okay, hello message is multicast on 224005. Okay, and router 1 will say this is my router ID and this is my neighbor router ID, and I have received already router ID of neighbor, so I know my neighbor. Okay, then router 2 will say that I received hello from R1 and I am listed as a neighbor, as his neighbor. Same here, R2 will also send like this. This is my router ID, this is my neighbor router ID, and this is the multicast IP where I want to multicast. Okay, once these two-way state will be exchanged, okay, hello packet will be exchanged in two-way state. Okay, in this situation they will form which neighbor? Just two-way neighbor, no database exchange, we are just neighbor.
Okay.
And always keep in mind here, in this two-way state, DR and BDR election will be formed on multi-access link. Multi-access link means that Ethernet family, Ethernet, fast Ethernet. Okay, so here they will form two-way also, and they will initialize that okay, you are DR or BDR. This one here. Okay, okay, they will form that okay, you are my neighbor, but you are DR, you are BDR, or you are DR other. Okay, these informations will be found here. Okay, DR and BDR. But if it is a point to point link, if it is a serial point to point link, then this state will not come. Okay, now after that, after two-way they will go for fourth state, which is known as X start. Okay, in S start what they are going to do, first four process will run here. First they will exchange empty database. Okay, and when they will exchange empty database, they will exchange the sequence number. Okay, and what they will do, they will negotiate the Mtu size. They will say that okay, what is your Mtu size? Then they will say okay, this is my Mtu size. Okay, and this will router 2 will say okay, this is my Mtu size. So if Mtu size will match, they will become neighbor. If not, then they will stuck here. Okay, so size must be same to become neighbor. Okay, and here they elect master and slave, that okay, who will become master, R1 will become master or R2 will become master. Okay, then they decided okay, this is master, and they have exchanged, see here, empty database, no full database. Okay, okay, now they will come here to the fifth state. In fifth state they will say that okay, that they will move to exchange state. In exchange state they will say that okay, number one, what they will do, LSA header exchange by DR. Why? Because here we have already came to know that who will be DR and who will be BDR, right? So the what you can say, the manager router, the boss router, okay, that router will be responsible for exchanging the database. But why it's R2 is boss? Why? Because R2 router ID and the priority is better than R1. Okay, that's why we'll come to know. Okay, then LSA header will be exchanged by non-DR router. Okay, non-DR router means R1 first R2 will exchange, then R1 will exchange. Okay, once the database LSA header will be exchanged, okay, now they will go for, now see what is saying, that only LSA header will be exchanged between neighbors. So
Okay.
here they have exchanged, but here header is exchanged, no full information, only header. And I will show you that, okay, what is LSA header and what is full LSA database, okay, LSDB. Okay, so here they will only exchange LSA header, and then once the header has been exchanged, means they will say that, okay, there is no any problem, then they will start loading it. In loading, routers will query one another, both router 1 will query to 2 and 2 will query to 1, okay, saying that, please, I received your header, but I haven't received your full database information. Okay, so please share the full database information, and that request is done by LSR, link state request. Okay, for asking for detailed LSA of the LSA header what they have exchanged here. Okay, then they will move to second, router will respond back with detailed LSA, which is LSU. Okay, and then LSU will be means LSA who will update, like if you will request, I will update you. Okay, so both will send this R1 will send LSR, this one will update. If this one will send LSR, R1 will update. Okay, after receiving LSU, router will send back as an acknowledgement, which is known as LSAC, and once the LSAC has been exchanged between neighbors, router will move to full state neighborship. That's why if you will see here in neighborship, see, you can see here full. Okay, okay, same information like neighborship state, like link, when the link is connected between two routers, when it comes up, first it will be in a down state, after that it will move to init state, and init state they will send hello message to the multicast IP with router ID, then they will form two-way state. Okay, after two-way state they will elect DR if needed. That's why it's written if needed, means if you are connected with Ethernet link, then DR is important, but if you are connected with serial link, no DR is important here. Okay, yes, then they will move to X start. Here they will exchange database packet, but only empty database packet. Then they will move to exchange. In exchange they will request for detailed database, and once the detailed database is received, then they will load and they will move to full state. But here, if you have down, init and two-way, if exchange all this information, then you will form a neighborship. Okay, neighbor. Okay, but once these X start exchange loading is done, okay, then you will be adjacent neighbor. Okay, adjacency. Okay, now same thing what we have already came to know, that in down what will be there. See here, in down indicates that no hello have been heard from the neighbor router. In init what will be there, indicates a hello packet have been heard from the neighbor, but two-way communication have not yet been initialized. Why? Because both router has to be, like hello packet will be exchanged, and then router ID also must be exchanged. Once the router ID will be exchanged, then there will be two. Here you will find two state. One is init, or maybe one is attempt. But where you will find attempt? See here, did you received any attempt here? No attempt. But attempt is also there. One attempt is there, but attempt is in, you will find in special condition when you have a special link which is non-broadcast multi-access. So in that you will have attempt only, no init. Okay, init you will find only in Ethernet and serial link. Now, two-way indicates that the bi-directional communication have been established between neighbors. Okay, and then hello packet have the neighbor field. That's why they are neighbor. Okay, and though the communication is considered as a two-way, once a router see its own router ID in the neighbor hello packet, then they will become neighbor. Okay, and one more thing, in this two-way, designated and backup designated routers are elected in this state if this is conditional, but if it is point to point, this state will not come, but if it is Ethernet, this will be there. Okay, in X start indicates that the routers are preparing to share link state information, send empty database to exchange a sequence number. Then Mtu size will be negotiated and it must match. If no match, then the neighborship will be stuck. Okay, and if match, then master and slave will be formed here, that it and who, and then once the master and slave is formed, then master will say that okay, ready, I am ready to exchange. Okay, means who will begin the exchange? Master will begin the exchange. So in exchange, what is exchange state will say indicates that the routers are exchanging database description packet. Okay, now dbd contains the description of the router topology database. Okay, and a router will examine a neighbor database to determine if it has information to share. Okay, and then they will exchange the information and then they will share. And then in loading, okay, in loading what they will say that initiate LSR means link state request indicates that the routers are finally exchanging LSA link state advertisement containing information about all links connected to each router. Okay, and once the request has been exchanged between neighbor, both neighbor will update with LSU, and once everything has been negotiated and updated between neighbors, exchanged between neighbors, then they will exchange with LSAC final acknowledgement that yes, everything is done, I have updated your information. Then they will move to full state, and full state means you are fully synchronized and your database will come up and your router will start communicating. Okay, now once you will become a neighbors, right, you have some neighbor type. Okay, so these all neighbor types you can check when you have a topology running. Okay, I'll show you this one. Neighbor type means, see, you have full dr, full bdr, full means two-way dr other, then full dash. Okay, so how you will come to know, but let me explain you here. But when you will see full slash dr indicating that the neighbor is designated router, means I have a fully synchronization within that neighbor, but that neighbor is dr. Okay, that but dr, but that is my adjacent neighbor. Here also if you'll see that means full synchronization means adjacent neighbor, but my neighbor is bdr, backup designated router. If dr will fail, then bdr will become dr, that's why it is there. Now two-way dr other, two-way means I we have only exchanged the two-way we came to two-way state only, and that my neighbor is non-designated. Okay, and then here you have full dash means uh, indicating that there is no dr and bdr election on this link, means this is a serial point to point link connectivity. Okay, all these neighborship states we will check in practical. Timers, I already told you that in ospf we have hello as a 10 and dead as a 40. Okay, now if it is LAN, that's why it is 10, but if it is WAN, so WAN is hello is 40. Okay, and dead is 160, and this is for LAN and this is for WAN. Okay, Now we'll see how to modify these timers also. Okay, so main thing is that like we have learned about
For the
EIGRP.
one, for the one, is it not 30 and 120?
Which one?
I'm talking about the hero time for the one.
Yeah, is 120 or one?
It's like 30 for the hero and
No, this
120.
is OSPF.
Okay.
Okay,
Okay, so it's not like a
it's not
AG.
like, yeah, we'll verify it. Don't worry.
Okay.
Okay. Now, see, as we talk about EIGRP, autonomous system number. So, what is the use of EIGRP autonomous system number? That if you want to be neighbor, you must have to be in a same autonomous system number, right?
Yes.
Okay. Now, so when EIGRP will multicast in that EIGRP domain, EIGRP router will multicast, and in that domain, if you have thousands of router, okay,
Okay.
so each router will receive those all informations. No, I'm asking from you. If thousand
Okay.
routers,
Come
if
again.
if thousand routers are there in EIGRP network, and one router will send
Yes.
multicast update, so all router will receive those informations.
In EIGRP or OSP,
EIGRP,
yeah, they will receive it.
yes. So, and then remaining router will also send hello packet acknowledgement, like that.
Yes.
So it will, like, so there will be, EIGRP will consume half of the bandwidth of your network just because of EIGRP message moving from one router to another
Yes.
router, right?
Yes.
Now, so it is one kind of multicast domain, right?
Yes.
Okay. Now, remember, in switching network, we have learned about something to break a large broadcast domain into a small broadcast domain, right?
Yes.
Why we did like that? To reduce the overhead and reduce the bandwidth utilization of the link.
Bandits. Yes.
So same here in
CPU.
OSPF, there is area concept. It's saying that no problem, if you have thousands of router, no problem, all will become neighbor, no problem. But what you do, you make some routers in a small area,
Okay.
you divide it. So
Okay.
inside one area, when you have router, so these all routers will communicate inside within area, these all routers will communicate inside area, okay, and this router will exchange information with this normally. Okay, and here is one router which is known as area border router. That router is responsible for exchanging database from one area to another area, right?
From
Okay,
one area to another one.
yes. So what he did,
Yes.
same like in in switching network, we divided, we broke the large broadcast domain into a small subdomains, right? Okay,
Yes.
yeah, or a small broadcast. So same here, if you have a large OSPF network, so instead of having, like, this uh, EIG, like OSPF is used by ISP, right? And in a
Okay.
big ISP network, you will find thousands of router, 2000 router, and millions of what you can say, like,
Switch.
routes,
Okay.
because we have around 7 point like 4.2 billions, right?
Yes.
Like 4.7 point, no, sorry, 4.2 billion, we have IP addresses, right?
IP address. Yes.
Yes. So, and we are using IPv6 routes also, so you can understand that how much route ISP is managing. And if there
Okay.
will be, like, single database in EIGRP, when we are talking EIGRP, and if you have 1000 routers, so all router will have same database, right?
Yes.
So if, do you think that router will be able to handle millions of routes? It will crash.
Yes. Yes.
That's why OSPF came with area concept to reduce CPU overhead. It said that in OSPF, is a single autonomous system domain, and it can be divided into a smaller groups, which is known as area. This reduces the number of link state advertisement LSA and other OSPF overhead traffic sends on the network. It reduces the size of the topology database on each router. Okay, and the router, when area 1 wants to communicate to area 2, no problem, it will communicate. But the broad multicasting and the database will be different. Area 1 database is different, area 2 database is different, area 3 database is different, but all will communicate. Now the routing devices that participate in OSPF routing performs one or more function based on their location in the network. Okay, now location means you belong to which area. Okay, now a
Okay.
router within an area must maintain a topology database for the area it belongs to. Yes, if I'm belonging to area 1, my database will be around like area 1. If I belongs to area 0, my database will be like this, my database will be like this. But see, database is different, but all routers will communicate to each other on the behalf of ABR will help you, area border router. Now
Yeah.
all routers within the same area shares a common OSPF database. Okay, so I told you. See, always keep a simple information that area is a concept of dividing a large OSPF network into a smaller or like OSPF network, I'm saying large OSPF database into a small database. So routers
Okay.
can easily manage those database and quickly they can perform the routing and quick communications. Okay,
Okay.
now OSPF, I told you that OSPF build one kind of router ID to identify himself in the network. That yes, I am our router 1, router 2 like this. Okay, so here they present themselves as a router ID. Okay, or you can say router ID is a ID to present routers in OSPF network. So the OSPF router ID is of 32-bit number, and it is in a IPv4 format. Now routers elect router ID to represent himself in OSPF domain. Each OSPF router is identical by unique router ID. I told you that router ID must be unique. Okay, and if it is different, they will not become neighbor. Okay, sorry, if it is same, then they will not become neighbor, and if it is different, then they will become neighbor. Okay, that's why it is talking about unique. Now router ID. Okay, election criteria. So we understood what is router ID, but how the router ID has been elected by routers. So there are two conditions: one is manually configured and dynamically allocated. Okay, now so if we are talking about manual configuration, so this is the way how we configure manual router ID.
Yes.
Okay, but if I haven't configured it manually, okay,
To
so
choose a loopback address.
yes, so it will choose the highest IP address
Yes.
configured on loopback. So if you have 4 loopback, so it will consider the highest one.
Yes.
And if you do not have loopback also, no loopback, no manual, then the highest IP address configured on the physical interface, right?
Okay.
That will become your
Yes.
router ID. Okay. Now OSPF router ID conditions. Okay. I think this is practical. So what we can do? Okay. Okay, so let me make one lab. Okay, in that lab I will explain you
Okay.
this OSPF neighbor conditions.
Okay.
Okay,
Okay.
okay. So let me make one simple lab first. Okay, so first I will show you here like Ospf neighbor type. Okay, so for that we can take one more router, and here we should use 29. Okay, so now here we will assign IP addresses. For that we can take a console of the devices. So
Number.
we are configuring IP address. So interface
Okay, that's it.
12.1.1.1 255.255.255.248. It's slash 29. Sorry, interface is 0 by 0, and then IP address.
Yes, yes.
See, I'm writing interface. IP address this no shut. Okay, save it. Now come to R2. Config interface is 0 by 0 IP address 12.1.1.2 no shut. Then come to R3. Config interface is 0 by 0 IP address 12.1.1.3 248 no shut. Save it. Now once the IP is configured, now we are configuring routing OSP. So we'll simply come here, router Ospf process ID 1 router ID. We'll define some ID 1.1.1.1, and then network. Let's make it default area
0.
0, and then exit. Come here also conf t router Ospf 1. Okay, router ID 2.2.2.2 network area 0. That's it. Now come here, conf t router Ospf 1.
We can even give additional router OSPF 2, 3.
Yes, no problem.
Okay.
Okay, network area 0. Now wait for the neighborship. E0 by 0 E0 by 0. So IP interface brief. It's okay. Now it's okay. It was taking some time, but now neighborship is
Yes.
okay. And now once the neighborship is okay, see here. Okay,
Okay.
neighborship came up, and you can see here the is now full neighborship. And now if we'll check here, so IP ospf neighbor. So here, see here, you are one, okay,
Yes.
and router 2 and router 3, okay. So you are saying that you are one, but router 3 is DR, means designated router, means he is the boss of this network, and he will be the responsible for exchanging database, okay. So now what will happen
Okay.
here, like if I'm coming here, suppose this is a slave router. If you will come to R3 to check, so IP ospf neighbor saying that, see here, dr other, right? Dr other means this router 1 will send update to R3, okay, and R3 will be responsible for updating to other routers in the network, okay. And you can see here as a, like, full means state have been, means like you are adjacent router, okay.
Okay.
And your, and who is, means like, see, you are R3 and you are getting information of R1. R1 means that is a full adjacent neighbor, but that is
Okay.
dr other, means that is slave router.
Okay.
Here R3 is saying that I have one router which is 2.2 as a neighbor, full adjacent neighbor, but that router is BDR neighbor, okay, backup designated router. Same here, R1 is getting this information. R1 is saying that I have one router, okay, who is DR, and I have one router who is BDR, okay. Okay, now I told you that we have one kind of neighbor also. When you will connect stat, like if I'm taking two routers, just R4 and R5 for practice, connect with serial 0 by serial 0. Okay, and here we are using this network. Start all the devices, take console, and R5 also take console. Now let's come here to R4. So it's separate. So I'm just showing you the neighbor type here.
Okay.
Quantity interface serial 2 by 0. IP address is 12.1.1.1. No shut. Router OSPF1. Router ID. If you will not assign router ID, okay,
Okay.
so it will consider your physical address, okay. So let's leave this router ID. Network 0000 sub wildcard mask and then area 0. Fine.
My light goes off.
Okay, so how long it will go? Means like your laptop will
I
run
don't
how
know.
long?
I have battery right now,
Okay,
so
fine.
maybe anyway.
Okay, then
More
interface
than
serial
30.
2/0, IP address is 12.1.1.2,
Okay.
no shut, then say router OSPF2 network area 0. Now wait for the neighborship. See, immediate neighborship, right? Okay, and now if
Yes.
you are coming to R4 and check here, so IP OSPF neighbor, see here you have neighborship, okay, but you can see here full neighborship adjacent but no state, Why? Because on serial link there
Yes.
is no serial link is a point to point link, okay, and in a point to point link there is no,
Okay.
yeah, there is no neighborship
Designated.
state, okay, no
No
drbdr, okay,
BTR.
yes,
Yes.
okay, and we wanted to check the timers. Now let's come to R1 to show you the ospf timers. So
Okay.
type here show ip ospf interface e0 by 0, okay, so ospf interface detail is not there, okay, 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 timeout, see here, hello is, see, you can see here, hello is 10 and dead is
Mhm.
40, okay,
That is for
yes,
yes.
okay. And if you want to change you can change, but once you will change it must be identical on both the routers. Like, see, let me show you. So
Yeah.
if I'm coming here on router 1 and I want to change, so if I'll come here interface e0 by 0, I will say here ip ospf hello
Yes.
interval, I will say instead of 10 I will say 5, okay,
Okay.
and you come here and check, see here it is 5 now, right? So this router
Yes.
R2 will come here as a neighborship, so IP ospf neighbor, it will wait for 40 seconds, right? Okay,
Okay.
and then you see that after that you'll see that neighbor will go down because hello timer must be, see, neighbor is down, can you see here, neighbor is down,
Yes. Yes.
and if once you will say that no problem, let me come here conf t hello interval, I will say 10, then you will see that neighbor will come up. See, neighbor came up, okay, we have seen
Yes.
the timer. Now ospf router id, okay, so if
Okay.
I'm coming on R1, okay, no, okay, suppose I'm here on R1, right? Okay, and if I
Yes.
want to check my router ID, so how I will check? See, if you type here, so IP protocol, see, you'll see that this is your router ID, right? Okay, we are talking about this lab. See, after this this lab, the lab what we created, we came to know about OSPF neighbor type, right? Okay, after
Yes.
type we came to know about timers, and after timer we are going to work with some router ID concepts, okay. So
Yes.
here I said that this is my router ID 1.1.1. Now if I'm coming here and I said okay, router OSPF 1 router ID I want to change to 11.11.11.11. Okay, now
Okay.
if your OSPF process is running, okay, and if you will
Yes.
try to change your router ID, right, so it will not update. If you want to change, see here, it will not update, see, it hasn't updated, right? Are you getting? And if you are coming to your neighbors also to check this, see, it
Okay.
hasn't updated it. And if you want to update the new router ID,
Yes.
so you have to run one command, okay,
Okay.
you, which command? See, clear IP ospf process,
Yes.
yes, enter, and then say yes, and it it will resynchronize with the neighbors. And if you'll check now, so IP protocol, see, it has been updated here, and after that if you'll check in your neighbor sites, see it is updated here, and this will go out, after 40 seconds. Okay,
Okay.
are you understanding? Yes, after 40 seconds.
Okay. I see.
Just wait for that 10 seconds. Now remaining 10 seconds, after that you'll see that 6, 5, 3, 2, 1. Now see it has gone. Okay,
I
now
see.
saying that one neighbor is
Yes.
down. Yes, of course one is down because now it's 11, right? Okay,
Okay.
now one more question. Now suppose if I'm coming here, let me stop, start, stop, start. So if I'm coming here, router 4, what happened? Start, start. Okay, so if I'm coming to R4, let's configure the IP address. Interface serial 2 by 0, IP address is 12.1.1.252, no shut. Let me save it. Now if I'm coming here, conf t router ospf, I will say pf1. Okay, then I will say router id 1.1.1.1, then network 0000 and 0000, and then area 0. Okay, now see if you'll check here, show IP protocol. Okay, so what is your router ID?
111.
111.
Yes.
Okay, now if you have your router ID as a 1111, and if you're coming here again to conf t, and if you're coming as a router OS ospf1 and router ID as 11.11.11.11, what do you think? It will be updated, or we need to update through clear IP OSPF process?
No, is it the point one? Yes.
Yes,
We need to update it.
updated. No, see, you can see here it is updated. No update. Why? Because
Automatically.
yes. Why? Because see here. Do you think that the database has been updated between the neighbors? So IP OSPF neighbor, no neighbor. So once I told you, remember I told you, once the database has been
Yeah. Okay.
exchanged upon
Okay.
that router ID, and if you are changing your
Okay.
router ID and you have already one neighbor, so at that time you have to refresh it with the clear IP OSPF
Yes.
process. But if your router is blank, no neighborship, you are just configuring, or maybe by mistake you have
Yeah.
configured some
Okay.
wrong.
For me, I thought you configured the other one.
Yes. So here what I wanted to make you understand, that if by mistake if you have configured some wrong router ID, okay,
Okay.
so it will update, and you can change it, no problem.
Okay.
Yes. But my point is that if database will be exchanged, then you have to refresh.
Oh,
If
okay.
no, then no problem.
Okay.
Okay, now my question is that how many, okay, how many router ID or how many processes you can run on a single router. Like if I'm on this router 2, right? Router 1, sorry. If I can come here conf t router ospf 1 is there, I came to 2, right?
Yes.
Okay. So I'm asking that how many process I can run, because if I'm coming here, let me come to exit.
Okay.
See, we have 65,535, right?
Yes.
Okay. So how many ospf process we can run on a single router?
As many as possible, or
As many as possible. Very good. So can we try?
let us try to see.
Okay. So we said router ospf 2. Okay. Exit.
Yes.
Then come to router ospf 3. See,
Fail.
fail, but 2 is accepted.
Yes. So just two.
Huh?
So it means that just two.
No. Now see. Okay. How many interface you have on this router?
Which router?
On router 1.
Just one.
Okay. 1. Okay. So we have enable process 1, right?
Yes.
Okay. So when we enable process 1, okay, let me, okay. So now here on this router we have single interface. So when you enable ospf 1, right? Okay, so remember we gave some router ID, right?
Yes.
So we gave router ID manually 1.1.1.1, right?
Yes.
Okay, so no problem, you can enable process. Okay, after that when I enabled ospf 2, did I give any router ID?
No.
No. So it has selected this interface IP as a router ID. You can come and check.
Not ID.
So IP protocols, router ospf 2. See, this interface ID as a
Yes.
ospf, and
Router
see
ID.
here is no router ID. That's why this process is not running.
Okay.
Okay. Now when you enable OS, so this is occupied, right? But when you enable ospf process ID 3, so no, you haven't assigned manually, right? No manually, and no
No.
automatic also, because for automatic this interface is already occupied with process
Yes.
number 2. So there was no
I can
any
see.
option to assign router ID on this router. That's why process number 3 was denied.
Yes.
But if I will
Yeah.
say I
Yeah.
want to enable process ID 3, see here, ospf process 3, okay, or
Router ID.
yes, or you will say that okay, no problem, conf t router ospf process 4, and then I will say here, see here, we got some error, right? Failed.
Yes.
But if you will say
Yes.
that router ID, see, and now if you run here, so protocol, see, for 4 you will find this.
Yes.
Okay, so you can create as much as, but for that you have to assign
But
manual
you
writer
have to assign router ID.
manually.
Okay.
Did you understood?
Okay. Yes. I see.
Okay, now we have this ospf basic configuration lab 1. Okay.
Okay.
Okay, so let me stop this video and let's work on the another video. Okay, otherwise it will be long. Okay,
Okay.
it's almost 1 hour with that video. So here we have
Okay.
okay, let's work on another.